bit about the cemetery project and give you some tips in regards to how to use Excel and also how to analyze your data. One thing I want to reiterate is that all GVSU students are entitled to have Microsoft Office, which includes Excel, Word, and I think PowerPoint. If you haven't downloaded the copy yet, I would strongly suggest it. Excel is kind of a fairly easy to use graphing program. It's the main one that students use for this project because it's pretty easy to do simple graphs. Word again is also very useful. Most of you have Word, I think. If you need a copy, what you should do is go to the Grand Valley webpage, go to Students, navigate here to Resources More, go to IT, and then over here it will say for students, and it will have, let's see. If you go scroll down to other resources, it will have software, hardware, apps, and then it will have this section right here, Office 365. Click here for download instructions. They're easy. Again, using your Grand Valley email or account and password, you'll be able to download a copy. So please do that if you haven't done that yet. And I will put a link to that on Blackboard as well. Okay, now this is a spreadsheet that a student did of their data from a cemetery. So you can see, the sex, the year of birth, year of death, the age of the person, which is easy to do in a spreadsheet. That is, you don't have to calculate it yourself. Excel actually is pretty good in terms of making formulas, right? So let's just say that you didn't want to calculate the age by hand for 100 people. Hopefully you haven't done that yet. What you could do is you could create a formula. The way you do that is you start off with an equal sign. Whenever Excel sees an equal sign, it knows that you are creating a formula. And then you would click on this box, and then you would go minus this box, right? So the death year minus the birth year, and you would get 84. Then what you do is if you go over to the square, you can see there's a little white cross. Once it turns black, you can stretch that down, and it will calculate the same using the same formula for the other cells beneath it. So it will do it for this and this, right? Getting age 55. So you can stretch this down for all 100 headstones, like you can see there, right? And so you will be able to do that without actually a lot. You can see it took me 5 seconds to do that versus a couple hours. Okay, so there's a couple things you can do in Excel in terms of formulas. That's the really good thing. The hard thing though is you can't just take your Excel spreadsheet and press a couple buttons and it will spit out graphs. It doesn't work that way, unfortunately. It would be great if it did. But what you actually have to do is you have to sort your data by different factors, right? And so what you do in order to sort your data, now this is very important, you go up to this button over here to select all of your data. Whenever you're sorting your data, you want to select all of the cells. Otherwise, if you selected one column and you went to data and sort, and you sorted only this column, it would sort it without connecting the other columns. So all the things that used to be connected would no longer be connected, right? So here they usually in Excel you can see they know that that's kind of a mistake, so it gave you the option to expand it to everything. But once you go to data and sort, you can then you click over here, my list has headers, so now each column will have the title at the top, and you could decide how you want to sort it. So maybe you want to sort it by the year of death, going in chronological order. And so now it sorts all of the headstones by the date of death. You can see starting with 1950. This person was born in, you can see, 1870. So that's pretty impressive. Maybe in order to, I don't know, maybe you feel like you want to sort it by the year of birth instead. This is up to you, but in many ways sorting it by the year of death makes more sense because that's when the headstone is being constructed, right? Okay, so then what you do is you have to then create tables in order to make things like a histogram. Okay, so in this example, a student has made, you can see, this table. This is one of the reasons why I wanted you to do that ethnicity assignment, so that you could get some practice with this. You did the same thing for that assignment, where you had different kinds of animals at the top, and then you had different restaurants on the side. And just by entering the numbers, but then doing a percentage histogram, it calculated the percentages for you, so you could compare the different restaurants to each other. It's the same idea, except that you might look at different time periods and then different variables up here. So here you can see this was mainly, I think, a Catholic cemetery. So the student decided to look at different kinds of Catholic iconography, like images of Jesus, Mary, the initials IHS, or a Chi Rho sign, and see how that changed over time. You could also do things like non-shared headstones, shared headstones, family plot, non-family plot. You could do something like ethnicity, different ethnic groups up here, so Polish, Irish, Dutch, etc. You could do the different kinds of stones, as I'll show you too. So there's lots of different variables you can use, and you can create different graphs. Now, what this student did, you can see over here, is they took this and they went up here and they did insert chart, and there are different ways to do this. You could either do it that way, or another way to do it is to go over to insert over here, and you can insert a chart that way. And again, remember, you want 100% stack column. If you did it this way, right, where they don't all add up to 100%, you're actually looking at the raw numbers. It's just really hard to interpret. Although what you do see, and this is something that you want to mention in your paper, you can see that there's only 2 right here. But you want to compare percentages. Now, as you're going to see, mostly on your own, with these time periods, the fewer time periods you have, the more headstones per time period you will have, obviously. If you create many time periods, right, then you're going to have fewer headstones per time period, and that actually can mess up your data a little bit, or your interpretations, because if one time period has 3 headstones only, and 2 of those headstones are one thing and another headstone is another, I mean, that's 60% are, let's say, of one category, and so it could be a little deceptive. Now, this student, you can see it's hard to look at change over time the way the student has it. What you actually want to do is you want to change it. You do a right click, you go select data, you go switch row and column, and now you can see it's a lot better because each column is a time period. So you could say, all right, percentage wise, in the early period, there was a lot more Chi-Rho. That was, or rosary. Is that the rosary or is that the Chi-Rho? It's hard to see using this. Let's see, rosary points. So there was a lot of rosary imagery, and that decreased through time. It was one of the most popular styles early on, and then it decreased. So, can we explain it? Possibly, but it shows that there is kind of a change in the way things are being expressed in this cemetery. Okay, this student also created, you can see, using the same time periods, and granite, red granite. I think they meant limestone here for stone, marble, and brass. Again, once they sorted their data, right, and here was their data. Once they sorted it by the year of death, right, so you would do it this way: data, sort, year of death. Right? Then they have to go through, let's say for each large time period, they will go through and say, okay, we've got 1 limestone, 2 limestone, 3 limestone, right? And then we have 1 granite, 1 red granite, 1 regular granite, right? So you actually have to, as you can see from the graph that they did, you actually have to enter that information in the table. So you have to sort your data, count by hand the different pieces of information for each category, and then you select all of the data, go insert, stacked histogram, and you create something like this. Right? So from this one, you can see that limestone tends to kind of decrease through time. Marble increases through time, as well as the gray granite or whatever they have over here, right? Now you can organize your iconography differently if you want. You can just do a category like religious, floral, or maybe different kinds of flowers. You might just want to do a floral, faunal, animals, plants. Inscriptions. No iconography is also a very important category. You can see that early on, and at least when this student was doing it, many, or in some cases almost half or more than half, had no iconography on them whatsoever. And that would be something you'd want to talk about in your paper. Why do early headstones have, let's say, less iconography or a different kind of iconography than headstones later on? Overall, what we see in this graph is there's more and more diversity later on. You might also want to have a category like personal. Many of you will see that more recent headstones have very personal kind of iconography to the person. Here you can see they did, again, the same kind of type of histogram, looking at headstone material. Right? You could see limestone here decreasing through time. They also did an analysis of shape, again, by different time periods. That's something you might do. Some of these graphs that you might try might yield not so much information. You can present that, but you want to see, you might try several graphs and several types of data until you find something that seems to demonstrate something to talk about in the paper. Here you can see size. Right here, that's something that you would estimate. Again, while you're reviewing your data, you'll put them into maybe 3 categories like small, medium, and large. And using the same table like you saw before, you can see these kind of trends over time. Now I want to also emphasize that as you start to work on your tables and your graphs, please email me if you would like to set up a Zoom chat where I can look at your data and your graphs and give you some pointers, put you in the right direction, or if you're having trouble and you can't figure out what you're doing wrong, we can figure it out together. Okay, another important kind of graph that you may try, I would suggest it. It's a little bit more challenging than the histograms, but it yields really good information. Our survivorship curves, like we talked about with our discussion of zooarchaeology. Now, I have some instructions to do the survivorship curve and how to use Excel to essentially create formulas. Now, essentially what a survivorship curve is you're using these age ranges, right? And you are trying to figure out, first, you're going to sort the data. You're going to sort it by the year of death, let's say. You're going to count how many people died during that time period of a certain age. So in this case, 5 people from 1865 to 1905 died before the age of 10 or below. Right? 2 people died between the ages of 11 and 20. Again, you have to go through your data once it's sorted and count how many in each of these categories. Now, what you then do is you figure out what percentage of the total. You can see the total right here. What you would do is you would select all of this, and then you would go to the sum bar over here, and that would give you the total of 19. Now, you want to figure out 5 is what percent of 19. The way you would do that is you make an equal sign, a parentheses. You would say this column divided by 19, right? You make sure you would, if not to just click on the 19, make sure to write the 19 in this case, times 100. And so here you have the different percentages. Now what you need to do is you need to figure out, let's say 26% die before the age of 10, right? That would lead 73% remaining. Now, in the next period, 10% of the total population dies. Now, what percent is remaining now? Well, you would have to do 73% minus 10%. So now there's only 63%, right? And so on, and then so on, until you get down to 0. So if you do your survivorship curve correctly, you will have something that starts out at around 100, right? And then ends up down to 0. You will never see it up and down. It's a steady decline down. It might be a sheer drop during certain age ranges, but it will only go down. And so in order to calculate it, what you can see here is in the first cell right here, you go 100 minus, and then you would do this cell. You would click enter and you would drag this down, and what it would do is then it would then take 73 minus 10, then it would take 63 minus 5, right? And so on and so on and so on. And that would save you a lot of time rather than, let's say, doing it by hand. You would then cut and paste these columns so that you can see here, so that you can then, right, you would have this as the x-axis and this as the y-axis. So you could either select them and then do an x and y column. There's different ways to do it. Okay, this student did some interesting things, but a couple of things that are a little harder to decipher, right? So again, if you don't use a stacked histogram, it can be difficult to figure out what's going on. But one thing that this student did, which I thought was really neat, is they also did an XY plot. They did the date of death, the year of death, and the age that person died, and they selected it, and they inserted, or they created a simple, let's see where it is, a simple scatter plot. And doing that, you could see if there's a correlation between the date when they died and the age that they reached. And you could even add a trend line, which is something that you can do by clicking on the graph, right? Like so. and doing, I think, selecting the data, you can actually, it might be a little bit different in Windows, but what you do is you select the chart over here, and then you go over to where it has chart design and add chart element. You could add a trend line. You usually want to add a linear trend line. And what this trend line does is it can tell you if it looks like there's a positive correlation. Usually you also want to have the R squared value. You know, this is getting a little bit into statistics. You know, you don't necessarily, I'm not going to require anyone to do that, but R squared will tell you how well the data fit that line, right? But overall, it looks like there's a positive correlation. The year you die is correlated to the age that you'll reach, which is not too surprising. If you essentially, it's saying that more recent people live longer in general than other people, than earlier people. So that's another thing you might want to try. Okay, so please try this. This is, we're going on week 12 here, and I want you to have one chart by the end of the week, so that, just to kind of get you going in terms of getting all the spreadsheet in order. And by the end of that week, end of week 12, you'll have made a chart, and you'll be in good shape to then make the other charts for your paper and also write up the paper. Now, please let me know if you want to do a Zoom chat where we can look at your data if you are having any trouble.